Welcome to our second tutorial about working with parameters. In this tutorial, we're going to try an exercise. I'm going to build a Lego block and then I'll use parameters to control its size. Let's start with a line. Right-click, done. Now let's apply some dimensions. This line's going to be 1 inch long, and you see that this dimension's got a name, D0. We're going to tie all the dimensions that I'll be using in this project to D0. Let's apply a fixed constraint next. Activate the rectangle tool and snap to the origin point. Apply dimensions here as well. Let's make this side 5/16 of an inch, but we'll enter that value with a formula. We'll click on D0 and then multiply it by 5/16. Again, the asterisk is the symbol you use for multiplication. Let's click OK. And let's do the same for this side. Click on D0, or you can type it in as well. Multiply it by 5/16. Click OK. And let's zoom in a little bit. Now let's activate the offset tool. I'm going to offset this square. Let's apply some dimensions now between these two lines. I'd like it to be 1/16 of an inch, but I'm going to use the formula for that, D0 divided by 16. OK. Lastly, I need to place a circle in the middle of this square. Let's dimension our circle. We'll make it 3/16 of an inch. Again, we'll use a formula, D0 multiplied by 3/16. Asterisk 3/16. And click OK. Right-click, done. Now let's say I want to use a radius dimension for my circle instead. Dimension. Right-click, radius. We'll enter a formula of D0 multiplied by 3/16, that's the diameter, and then divide that by 2. /2. In other words, 3/32. Let's click OK. Next, we can add 2 more dimensions. I'd like to place this circle in the middle of this square. To do so, we can simply place a diagonal line here and snap the center of the circle to the midpoint of this line. This will work if we only have one cylindrical piece on top of the block. In other words, the smallest Lego block piece, a onesie, as my son calls it. However, once we increase the length and width of the block, that circle will move. So how will we create twosies and foursies? For this reason, we're going to need to tie the position of the circle to this corner. Since this side here is 5/8 of an inch, we can do it with a formula, D0 multiplied by 2.5/16. Or you can use 5/32. Let's click OK. And our last dimension. We'll make it equal to this dimension, so select it and click OK. Alternatively, we can apply a tangent relation between the circles and these two lines. Right-click, done. Let's test our sketch out. I'm going to change this dimension to 2 inches. Let's click OK. The sketch changes, obviously, but the relation between the entities in the sketch remains the same. Let's return dimension D0 back to 1 inch and click Finish Sketch. Take an isometric view. Let's make an extrusion. Activate the Extrude command. Let's select all profiles. The extrusion is going to be 3/8 of an inch in length. Again, let's do this with a formula, D0 multiplied by 3/8. Click OK. Next, we'll create a cylindrical feature on top of the block. That's the little plug that connects one block to the other. It'll be 1/16 of an inch in height. To do this, I'm going to use a work plane. I'll offset it by 1/16 of an inch using the formula D0/16. OK. Let's share this sketch. Right-click, Share Sketch. Now activate the Extrude command. Under Extents, let's use From To. Let's select our profiles now. And this face. And the plane. OK. Let's right-click and hide Work Plane 1, Visibility. Lastly, we need to create a cavity inside the block. The depth will be 3/8 of an inch minus the thickness of the wall, 1/16 of an inch, or D3. Let's make an extruded cut, opposite direction, and click OK. By the way, we see this dimension that represents the thickness of the wall. Right now it says 0.63 on my workspace, but we know that 1/16 of an inch is actually 0.0625. That's actually what's grayed out in the value box. If we increase the precision to 4 decimal places, the workspace dimension will read more accurately. Let's apply and OK, and now we see 0.0625 out here. The same is true for 5/16 of an inch. Let's right-click on the dimension and select Dimension Properties. We've got 4 decimal points grayed out in the value box, 0.3125. Let's cancel out for now. Now let's go to the Manage tab and back to the Parameters window. We're going to write some formulas now. You might be thinking that for such a small part as a single Lego onesie, we've already got a lot of parameters. You can easily see how this list can become really long, really fast. One way to keep the list of model parameters smaller is to use constraints instead of dimensions. For example, here, as I mentioned before, I could have used a tangent constraint. I can delete these dimensions, apply the tangent constraint to the circle and the edge of the square. Let's finish the sketch. Back to the Parameters window, Manage tab, Parameters. Now we've got 2 fewer model parameters than we had previously. To find out which dimensions are related to which geometry, you simply mouse over them and you see a callout. But that's actually a real pain in the butt if you've got a lot of parameters. The easiest thing to do is to rename the dimensions more descriptively so you know what they are at a glance. Right-click, Dimension Properties, and in the Name value field we can simply give a more appropriate name. Let's call this L1, apply and OK. That's for length. Let's rename this dimension width. Right-click, Dimension Properties. We'll call it W1. Apply and OK. Let's go back to the Parameters dialog window. Here's my new dimension names, L1 and W1. And now it's time to write some formulas. Let's add some user parameters. We'll call the first one var1 or variable1. And you'll see why in a moment. The unit, let's leave it unitless, UL. OK. Under Equation, let's enter a value of 1. Now let's go to L1. Let's multiply the existing formula by var1. What I've done here, the smallest Lego block, the onesie, is 5/16 of an inch by 5/16 of an inch. Now in order to make it twice as long, let's change it to, for example, 2 to make a twosie. We will use this variable to adjust the length of our Lego blocks. This will let us keep the model parameter formulas simple. I'm going to change it back to 1, and before we go check out how this works in our workspace, let's create a variable to manage the width, variable 2. The units, also UL, unitless, and click OK. For the equation column, let's enter a value of 1. Click outside to register, and let's go to the width column. Now we'll multiply this formula by variable 2. Right now we've got the variables for increasing the length and width set up, so let's go back to our workspace and check out how it works. We're going to need to figure out how to control the cylindrical feature. Let's select the rectangular pattern tool. Feature to pattern. We'll select the cylindrical entity. Direction 1. Let's use this direction. Number of instances, 1. And the spacing between the instances, let's make it D0 multiplied by 5/16. The same thing for direction 2. This direction, 1 instance, and same formula, D0 multiplied by 5/16. Let's click OK. Now let's return to the Parameters dialog window. Down below we see 4 new parameters. The number of instances, 1. The number of instances is 1 here also. If you're not sure which direction is which, you can test by changing the value here. Let's try 2 and click Update. We now know that direction 1 relates to the length of the block. Let's go back to the Parameters dialog window. Change this value to 1. And let's rename the dimension so that it's more appropriate and descriptive. We'll call it dir1. And while we're at it, let's rename D20 direction 2. Now let's continue creating formulas. 1 multiplied by variable 1, and here multiplied by variable 2. Let's go check how it all works together. We're going to change variable 1's value to 2 and select Done. Now click Update. And here's our 2Z. Let's go back to the Parameters dialog window. Let's change variable 1 to 3 and variable 2 to 4. Click Done and Update. We've got a mini platform now. Since our entire part is controlled by this dimension, let's change D0's value to, let's say, 1.75 inches. Click OK and update the model. As you see, everything is larger, but the relationships remain the same. Let's change the value of D0 back to 1 inch and update. We'll of course need to save this part now. This concludes our second tutorial about using parameters. In our next tutorial, we're going to learn how to calculate the surface area, volume, and mass using parameters.